Welcome back. Let's do our last question, question 10. In the diagram below, K, H, and G are points on the circle. K, H, and G are points on the circle. And FG is a tangent. FG, where is FG? Oh, yeah, FG, this one. FG is a tangent to the circle with center E. Semicircle. This is the semicircle with center F. So we have center F here for the semicircle. We have center E here for this circle where there is point G, K, and H. Alright, semicircle with center F is drawn. Points D and E lie on the semicircle. CT, we have CT, and CE are tangents to the semicircle at D. So tangents to the semicircle, tangent to the circle is just the same thing, isn't it? Alright, and then at D and E respectively. And then we're given that DC is parallel to HE. Right, let's look at the key points here. Let's look at the key points in our diagram. Right, FG is a tangent to the circle. Right, we have FG being the tangent to the circle. Remember the tangent theorems, tan chord theorem, right? Tangent radius or tangent diameter, or tangent perpendicular to radius, tangent perpendicular to diameter, isn't it? Semicircle with center F is drawn. Points D and E lie on the semicircle. CD and CE are tangents to the semicircle. Now again, there's another one, tangents from the same point, isn't it? CD is parallel to HE. Remember, geometry of parallel lines, alternate angles, corresponding angles, co-interior angles. Right, give a reason why DC and EC are equal. Right, DC and CE are tangents. And then what do you know about tangents from the same point? Tangents from the same point are equal. So your reason you write there, you say tangents from the same point. Right, remember this. Two tangents drawn to a circle from the same point outside the circle are equal in length. Two tangents drawn from the same point, like these two tangents are drawn from C, right, from a point which is outside the circle, right, these two tangents are equal in length. So the reason you write, just write tangents from the same point or tangents from the common point. (10.2) We are required to prove that triangle DCE is similar to triangle HEK. Let's highlight our two triangles. Right, we have our two triangles, the green triangle, which is triangle DCE, and then the blue triangle, which is triangle HEK. Actually, this is guiding us. We're saying angle D, which is this angle, should be equal to angle H. Angle D should be equal to angle H. Right, angle C should be equal to angle E. So it's going to be E2. So angle C should be equal to angle E2 there. And then angle E in triangle DCE, it will be E1. Angle E should be equal to angle K. So this is angle E should be equal to angle K1 here in this triangle HEK. You see that? So this is guiding us somehow. So the easy one to find will be this angle D. This will be angle C and angle E2, right? Why is angle C and angle E2 equal? Why are these two angles equal? It's very simple to find this one. Because there are alternate angles, right? DC is parallel to EH and EC there is the transversal. So we can say that in triangle DCE and triangle HEK, we can say that angle C is equal to angle E2, right? Reason alternate angles, right? DC is parallel to EH, right? Okay, now we need to find the other angles, angle D and angle H, and then angle E and angle K. All right, so we have to observe something here. So we're saying this angle E2 is just the same as angle C, so we can write angle C here. And then let's just try to recognize something before we do our calculations, right? This angle D will be equal to angle E1, isn't it? Because these angles are what? Are angles opposite equal sides. DC is equal to CE, right? And then again, this angle will be equal to this angle. Since they are angles opposite equal sides, EK is equal to EH since they are radii. You see that? And then since angle C is equal to angle E2, it means that these angles K1 and angle E1 are equal, angle H and angle D are equal, because you just say, how do you find angle K1, for example, or angle H? Let's talk about angle H and angle D. How do you find angle H and angle D? You say 180. Let's look at triangle DCE. You say 180 minus C divided by 2, isn't it? Because angle D and angle E1 are equal. So you say 180 minus C divided by 2, isn't it? Okay, we're going to write nicely after this. Let's just discuss first. And then here, when you come to angle H again, we are going to say 180 minus E2. But we're saying E2 is equal to C. So we can as well say 180 minus C divided by 2 again. Do you see that we have the same things here? Okay, let me try to write this. Maybe it's going to make sense when I do the writing. Right, let's start. We say that this one is done. So we're saying angle D plus angle E1 plus angle C, right? This is equal to 180 degrees, because sum of angles in triangle, isn't it? All right, and then but we're saying angle D is equal to angle E1. What's the reason? These are angles opposite equal sides, right? So angle D is equal to angle E1. So it means that where there's angle E1, we can replace it with angle D. So it becomes angle D plus angle D, which is 2 times angle D. 2 times angle D plus C is equal to 180 degrees, right? And then what would be angle D? Angle D would be equal to 180 degrees minus C, isn't it? Divided by 2, right? Let's talk about angle H now, right? We'll do the same process. We're saying angle H plus angle K1 plus angle E2 is equal to 180 degrees, isn't it? This is in triangle HEK. Then there is in sum of angles in triangle, right? But angle K1 is equal to angle H, right? What's the reason? But angle H is equal to angle K1. What's the reason? Angles opposite equal sides. Angles opposite equal sides. So where there's angle K1, we can replace it with angle H. All right, so we can say this is 2 times angle H, because angle H plus angle H, that is 2H, and then is equal to 180 degrees minus E2, right? But what did we say about E2 part? We said angle C is equal to angle E2, isn't it? We say that. We prove that. Okay, we say that. So what does that mean? So it means now where there's angle E2, we can put angle C there. And then say angle 2H is equal to 180 degrees minus angle C, right? Meaning that angle H is equal to 180 degrees minus angle C divided by 2, right? And then now check angle D. Then check angle H. Are they not equal? They are equal. So therefore angle D is equal to angle H. Right, so we have proved two pairs of corresponding sides being equal, so automatically the third pair also becomes equal. So there's no need to do that, but if you want, you can even say therefore what, angle E1 is equal to angle K1. Right, we can write third angle of triangle. Therefore triangle DCE is similar to triangle HEK. Then reason angle. We need to prove that DG is equal to GE. We need to prove that this is equal to this. Alright, what are we given here? We're told that FG is the tangent, and then GE is the radius. And then we know that radius and tangent are what? Are perpendicular. So we can say that angle FGE is equal to 90 degrees. And then the reason you write there, say tangent perpendicular to radius. Okay, right? And then what do you know about a line drawn from the center? Because F is the center of the semicircle. So FG is a line drawn from the center perpendicular to the chord. DE is the chord of this semicircle. Okay, so line drawn from the center perpendicular to the chord will what? Will bisect the chord. Right, therefore we can say that DG is equal to GE. And then the reason, right, line from center perpendicular to chord. Line from center perpendicular to chord. Okay, right, and then we managed to prove that. Okay, let's do the last part. All right, we've managed to prove this. So now it says show that 2HE squared is equal to DC times HK. Right, from this statement, what can we say? DC over HE is equal to CE over EK, and then DE over HK, right, and then DE over HK. And then the reason you can write similar triangles. Okay, or you can write this statement as it is, like this. Okay, all right, so now we have HE here, DC, we have DC there, HK, we have HK there, but we don't have DE. But DE, let's check DE. Oh, there's something we talked about DE here. We said DE is divided into two equal parts, DG and GE, right? And then GE is the radius here. We can bring this HE into the equation, isn't it? Because HE is the radius, GE is also the radius. So we can bring this HE. Okay, so let's use these two, right? So we're saying DC over HE is equal to DE over HK. Then cross multiply. If we cross multiply this will give us this part. Okay, and then if we cross multiply this will give us HE times DE is equal to DC times HK. Right, it's promising because we have this part now. But now, how do we get rid of this DE? Okay, DE will be what? DE will be 2 times HE. Okay, DE will be 2 times HE because HE is just equal to GE. Right, HE is equal to GE. So we can say, let's write that. GE is equal to HE. And then the reason you write there, you can say radii. Therefore, DE is equal to 2 times HE. Since DE is 2 times GE, isn't it? Where there's DE, we're going to put 2 HE. So it's HE times 2 times HE is equal to DC times HK. Right, and then 2HE squared is equal to DC times HK. Right. Oh, we've managed to prove that. Okay.